Welcome to a video by Datum Systems International. Today, we will learn about PointTranslator, a tool to add and manipulate point data in your sessions. PointTranslator is part of the Summit Evolution and Landscape programs within the Datum Photogrammetric Suite. PointTranslator is a multifaceted way to organize point data to bring into Summit and Landscape environments. In here, you can regrid points, convert them to another coordinate system, redistribute points, and color them using values from an ortho image. In this video, I will show you each of the tabs and how to bring in and use the data. You can access PointTranslator in one of several ways. It is on the toolbars in Summit and Landscape and under their drop-down menus. In Summit, click under the tool under the Terrain tab. In Landscape, you can find it under the Tools menu. Alternatively, you can access it from the Windows Explorer window by typing PointTranslator in the search bar. Let's look at each tab in turn. The first tab, Input, logically allows you to bring in various types of point files. PointTranslator allows for over 20 different extensions, including those from the various mapping programs, as well as text and XYZ files. These are two types of text files, as the XYZ extension is treated in PointTranslator as a text file. Originally, XYZ was a LiDAR format, but with the rise of the LAS files, XYZ is rarely used and, as such, is no longer considered a true point format. You can use XYZ files in PointTranslator, and it will attempt to read them as text files, although not always with the same success. Now, because many bring in text delimited files or the XYZ type of text files, I will mention the special application needed to make these files usable. That is, this is what you must do to create a workable format from text files. Make sure that the data are organized by column and then labeled, that your file structure has some delimiter between the fields. Let us look at the tab. Go to the Input tab and click Add Files. Add a text file. If you look to the right side under the header Text Format, you may see a format already assigned. The last format used is automatically assigned to any subsequent files. But I can change that easily enough. Click on the file you want to change, and then click on Change Text Format. I can use an existing format, or I can create a new format here. Let us look at the existing format option. Click Next and look under Format Name. Click on the drop-down to see the list of those files already created. These are all attached to the TXT format. Remember that XYZ is also treated as a text format. However, any format you create is limited to that extension, so TXT and XYZ have different formats and are not available for the other extension. The format name here will bring up the settings created previously, the delimiting style, and field names. In this example, the first fields are X, Y, and Z coordinates, and then any field to the right of that are to be skipped during importing. If I accept this format, I can click on Finish, and now you can see the changed format. If I bring in another text file, it will adopt that new format. But I can change that if I wish by selecting the file and clicking on Change Text Format again. If I add XYZ files, you will notice that its text format is different. I will create a new text format for this file. Click Create New Format and then Next. Both text and XYZ require some type of field delimiter. Look at your data file to see what delimiter you need. In this file, I see that the first few lines are header information, which I do not want to import. I will increment the start import at a record until I get to the first row of data. In this instance, I will start the import at record 13. Now I can look at the records to see an obvious delimiter, spaces between each field. Therefore, under the Field Delimiter box, I will click on the Space button. Now I have demarcation lines separating each field. If I do not have separation lines between fields, then I will click another option until all the fields are separated. When that is done, click Next. And here I can label each field by type. I know the first one is the X coordinate, followed by the Y and then the Z coordinate fields. So I will highlight each field and click on that label. The other fields may contain specific information like color or flight line numbers. The default option for all fields is to skip importing them so we can avoid labeling each field whether we want them or not. If you need to change the label for any field, simply highlight the field and choose another label. When you are done, click Finish. Now you can choose a format name, which can be descriptive or as generic as you like. This name will now be available for all other files with the XYZ extension. Now any other file type you add will be accepted as is. That is, you will not be able to add any filters or delimiters, with one exception, the LAS or LiDAR files. You can change or edit the LiDAR filters using icons in the lower right of the Input tab. Click on the LAS file and select an option under the No Filter drop-down box, or click the triangle to edit the filter. This information is beyond the scope of this training video, but I will address it in a future training session. Once you input all the required files, select the Grid tab. Grid creates new files of data points contained within an assigned vector boundary file or from a defined grid. This defined grid can incorporate all data within your working area, or you may select a subsection of one or more input files. You do not need to use this tab if the area in your input file will have the same geographic extent in the output file. Let us examine the Select Ground Size option. In this case, I want to find the extent of my data, so by using the SI LiDAR tool in Summit, which is here under the SI drop-down menu, I can look at the range extents of the displayed input files. From there, I can find the minimum and maximum coordinates in the XY plane. So in this example, notice the lower left coordinates. I will use these to define the origin of my grid. I would like the grid size to be 400 by 500 US feet, the feet being the ground units of my data. If I want a non-square grid, I would click this chain link icon next to the height. That will unconstrain these properties so I can add different values for width and height. But for now, I will keep the squares. So here is an illustration of what I indicated in the tab so far. Note that the origin point is in the lower left and has these significant digits for both the X and Y coordinates of this vector boundary. Now rather than have extra decimal numbers for the X and Y, I would prefer the grid sized as whole numbers, so I will check the Start at Nearest Multiple Of and enter 100. Again, that is the ground unit of my data, US feet. This means that the origin of the vector boundary, the lower left coordinate, is shifted to the nearest 100 feet. Here, the grid distance value is evenly divided into both the X and Y values. So notice the location of the lowest coordinate point from before and where it is in the new grid. This grid will encompass the entire area of my input files, thus ensuring all points are contained. But what if I want to rotate the grid, or not even use a regular grid to cover an irregular area? In this case, I can choose Select Boundary File and add a pre-drawn vector file that will cover the points I want for the shape and orientation I require. Here are two examples. The first is a grid created in a drawing program, then rotated. The second is a vector file drawn in Summit. So now that I have the boundary defined, I can assign a name to the resulting files, and there are several options here. The prefix naming will append a phrase to each output file, which is numbered sequentially. In this example, all the files will begin with Project D. Or you can name them based on the coordinates of a corner, which is a benefit to creating a grid file with integers. Choose whichever corner you like for this naming. If you created a boundary file as a drawing or a DGN and labeled the polygon, you can assign that text label as the file name. In my grid example, each output would be named file name 1, file name 2, file name 3, and so on. So uncheck the box if you prefer not to use the boundary name, as it will take precedence over the other two options. Click on the Conversion tab. You will use conversion to change your horizontal or vertical coordinate systems, which can be either a preliminary step or as a standalone exercise before distributing your points. You will use this if you are bringing in disparate point files, any or all of which may have different coordinate systems, or you need to change the current system to match other files in a project. Regardless of the number of files you need to convert, each file will have to be converted in a separate instance of PointTranslator. If this tab is ghosted, that means you have selected the Distribute Points button in the Distribute tab. PointTranslator will not let you both convert and distribute points within the same instance. So convert your points first, then input those resulting files into PointTranslator, then continue with your other options. Also remember that you must convert to rectangular coordinate systems if you plan to distribute your points data, and if your data are in latitude and longitude, you need to convert them to decimal degrees rather than degrees, minutes, seconds. If you do not see the coordinate systems you want listed in the database, then chances are that you do not have the current version of Blue Marble's elevation database installed. Exit PointTranslator and install the free software, which you can download from the Datum website under the Support tab. To perform the conversion, click on the Convert Points checkbox, then indicate your current coordinate system. You can bring up data source information. You can also select point styles, and you can select a vertical reference. If you are so inclined, you can click on the globe icon to create or edit a data source. Repeat these steps to set your output conversion format. Here you can indicate the datum transformation required, and as with the current coordinate system inputs, you can edit or create a new output format. PointTranslator has a vast number of programmed formats available, but if what you require for your project is not there, feel free to create your own. If, however, you need a new geoid, please contact Datum support. Geoids are generally too complicated for users to add and therefore must be added by Blue Marble. The Distribute tab allows you to evenly space your points within the established grids, or it will change the grid spacing of your point data. This is of course very useful if you have large LiDAR point files. It will take densely packed data and thinify it. Note, you cannot densify sparsely plotted data because PointTranslator cannot accurately interpolate between values. It will only take a dense arrangement and reduce them to create evenly spaced grids. You will use this tool if you want to change your point density or if you want to create a new evenly spaced point grid at a specified angle, for instance, to match the orientation of the imaging source. The input points must be in a rectangular coordinate system, usually with feet or meter units. Do not try to distribute points in latitude and longitude coordinates and degree units, because you cannot make an even rectangular grid in a non-rectangular system. Click the Distribute Points checkbox to see the options you may select. The grid size box allows you to set the new spacing between points. This distance is in the same units of measurement as assigned to your data. In this instance, I'm using US feet, so each grid point is 20 US feet from another. The new value you choose must be equal to or larger than the original grid spacing. Compare the number of resulting points you will get from various grid sizes by clicking on the point estimate box. If you have a very densely packed LiDAR cloud with millions of points, the point estimate will assist you with choosing an optimal grid size for your project. You may elect to add smoothing to your points. The drop-down menu offers a choice of no smoothing or 1, 2, or 3 values. The higher the number, the more smoothing is applied. That is, the values are evened out so that outlier data do not adversely affect the distribution. These outliers may be a different type of data or have a vertical height that is not consistent with its neighboring points. This may not be required for your data, so select None here. You can adjust the angle of your resulting grid to better match the kappa value or the angle of the acquisition source. Click the Use Angle checkbox and drag the red arrow around the compass to set your orientation. If you wish to select 0 degrees, simply uncheck the box for that default direction. Remember that if you check the Distribute Points box, you will overwrite the command for conversion, as you cannot run both commands in the same instance. Select the Colorize tab. This step will allow you to color grid cells to develop depth of color, allowing you to better visualize the data or to change existing colors in your data. This is accomplished by adding a geographically similar orthophoto image. These orthophotos must be in the same coordinate system as your point data. If not, first convert your orthophoto in a separate instance of PointTranslator before beginning this step. If, however, you are using data with RGB values already assigned, such as LiDAR or some ASCII files, and do not wish to change these colors, you can simply skip this step. Import ortho images that cover your entire area. Then choose a default color to illustrate areas that have no associated imagery. After that, choose your cache size. The default cache size is 400 megabytes, and you only need to increase this number if you require higher resolution output. 2 additional caveats: your output files must be bin or LAS version 2 or higher, because those are the only ones that retain color values. You also cannot distribute points within the grid, since the color values are added directly to known points. That is, a color value in an orthophoto point is directly associated with its value in the dataset. Distributing points means that association is lost, as PointTranslator cannot interpolate a color value. Now that you have set your information in the various tabs, go to the Output tab. This is where you will generate your results of individual tabs or combinations of tabs. This is also the place where you can merge multiple files. You can save the PointTranslator settings as a reg file and pass them to another PointTranslator user, provided they are running the same version of the program. There will be more output formats in future versions of this program. Here are the available ones to date with which you can assign your results. The ASCII files will require either the TXT or XYZ extensions, and you can also set your level of precision, the number of significant digits your project requires. As with the Input tab, you can change your ASCII format setup here by clicking the ASCII Format button. Some users need to change an XYZ file to a YXZ format, for example. Therefore, select the Create New Format button. We recommend that if you plan to use your output in Summit, Landscape, or Datum's Ortho Mosaic, that you save them as bin or LAS files. Click here if you want to merge your files. If you see this warning that you cannot merge, that is because you selected Create New Files by Grid or Boundaries under the Grid tab. Create Grid and Merge are opposing tasks. Create Grid is a way to split the output into multiple files, while Merge is a way to combine the output into one file. You cannot do both at the same time. This has a two-step solution. Create your output files first, then input those new files into PointTranslator and select the Merge button in the Output tab. making sure that the grid button is still not selected. Then assign a file name and its output folder. If you want to create a datum landscape project that references the output file or files, check that box and provide a file name. Using landscape is a good way to verify your output files. Finally, click the Generate button. The speed of processing depends on several factors, such as the number of input files, the density of points within the files, the number of operations you set in the tabs, and the processor speed of your computer. In general, if your input files are ASCII files, they will take longer to read than binary formats, such as LAS or bin. When finished, you may use the output in datum applications, such as in the Summit Stereo Plotter's terrain following and contour visualization tools, as input for Contour Creator, or by opening the Generated Landscape project. That concludes our video about PointTranslator. Thank you for watching. You can find more videos on our website at datum.com. If you have any questions or comments, or wish to suggest topics for future training videos, please contact us at support@datum.com or through the contact information on the screen now. We post lots of great tips and updates on our social sites, so if you do not already follow us, please do. We also have a monthly newsletter, Control Points. When you sign up, you'll be the first to learn about our software updates and gain immediate access to our latest videos. You can sign up for Control Points at datum.com/controlpoints. Thanks again for joining us.